So this is Victoria Vanlue's project. It's a build of a small RISC-V operating system, a kernel, and it boots into a shell on QEMU. It has 12 commands. It has its own memory manager within 8 megabyte heap. It keeps track of up to 16 processes and includes a small in-memory file system, and it implements system calls such as fork or write. It uses spin locks for basic synchronization across the system, and everything from the booting to the running commands happen without any underlying operating system, so the kernel handles all of the hardware details on its own. What's interesting or unique about it is there's no standard libraries and there's no error handling, so there's no safety net. And all of the tools and the structures are built specifically for it, so the entire operating system is only about a dozen files with 100 lines of code each. Some parts aren't fully finished, but it has enough pieces to show how a true operating system might work. The process control block is here. It's the structure that has all of the important information about the process. It keeps the PID, the current state, which can be ready, running, sleeping, or zombie. It has the process name, the safe CPU registers, and it has a pointer to a 4 kilobyte stack that gets allocated from the heap. It keeps track of the parent process, the exit code, the process priority, and how much CPU time it's used. And all of the processes are stored in that one global table. And when it runs the fork, it finds the empty slot, it copies that parent's data, and it gives it a new PID, and then sets up a stack for that job. And it doesn't have any real context switching, but even besides that, it's basically how a real operating system would manage processes. How I tested, I would generate the code in ChatGPT or Claude, copy it, put it all in to my actual file, and then make it, run it, and then see what happens. For the beginning of it, errors would print, and I would just copy the entire error, paste it into that AI, and then whatever it spits out, I would read through those options and choose the one that seemed like the best option. And I would just do that again and again until all the errors were solved and I got the result that I wanted. What's happening more recently, there is no error message, so I would go back into certain files and just copy and paste that code and then ask if there might be something that's wrong with the code and what could possibly be fixed. It's working now. In comparison to what used to happen, it would print errors such as when it showed this giant wall of text if I didn't include the BIOS none, and it showed errors such as like waiting on unfinished jobs or no rule to do whatever was needed. And when I used AI to problem solve that got me to the point that I'm at now. What works well is the make file. Everything will make correctly, and it does create the correct files such as kernel.elf, boot.o, and kernel.bin, and you can run make clean and they do actually delete. It does compile in a sense as it runs to a point where I can terminate it in QEMU and I can see that pop up and there are no errors that come up. Although there are no errors or warnings that pop up, it is incomplete. Nothing happens when it runs, nothing prints to the terminal. I've tried multiple different versions. I tried a simple one that just prints and says that it's running. I tried one with only one feature with switching. I tried one that had multiple features. I tried ChatGPT and Claude. Neither of them could figure out a solution. So that is the serious limitation of my build. In reflection of using AI during a development process, I use ChatGPT at first. It's quick and its responses are easier to understand, but it wasn't creating any working option. There's so many errors. Anytime I would use AI to fix it, it would generate another error. Claude was better in the sense that it would actually take what I asked it and give me a working solution, but it still did not give me a working build in totality. It did those small things, and now it's at a point where it can't answer any questions that I ask in relation to my project. So using AI, I found in this project, definitely is a crutch. It doesn't seem to be able to think critically, so bug fixing is a very, very heavy task because it cannot think of something new that might be throwing it off. It can't just generate an entire list of, go through this file, go through that file, see what happens. It's very slow in the sense of finding the right thing that's off about your project. So I think relying on AI definitely prevented me from finishing a complete build of something that would fully work. But the benefit is that it did create code that looks and sounds correct and professional in a sense. And you can have it correctly explain what that code is doing. So for learning, it is a great tool, but just not for building something that really, really works.